Let ABC be an equilateral triangle with each side of length K. If a circle is drawn with diameter AB, then the area of the portion of the triangle lying inside the triangle. Okay. Side K. I'm going to put C here to make my diagram simpler. Usually I like putting A there, but here diameter AB. Then draw a circle. If a circle is drawn with diameter AB, the area of the portion of the triangle lying inside the circle is. So we want to find this area. Very interesting question. It's an equilateral triangle. So side A, so radius of the circle is K by 2. Side is K, radius is K by 2. So we have to figure out some way of getting this. And so we can say from the triangle, subtract the semicircle. That doesn't work because this part is out. We can somehow locate these two segments, which is fine. Then we can say from the semicircle, I subtract these two segments. I'll get area remaining. And how do I find this segment? We'll figure that out. Right? From the semicircle, I subtract this segment and this segment. I'll get area of the shaded region. Or I can say, hey, this is very interesting. I can draw this chord, point joining those two. This is K by 2, this is K by 2, 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 all similar triangles, congruent triangles, K by 2, 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 K by 2. I can say here there are 3 equilateral triangles of sides K by 2, and then I have to get that segment, add that up. And how do I find that segment? I can say, look, I know how to find segment area, sector minus triangle. You can figure that out, I'm through. And so I'm going to do one of these two approaches. So let's see how we can simplify this. We've got the approach now, let's do the math. Math is also tough. So this is a circle like this of radius. This is C, A, B, O, K by 2. Area of semicircle is pi into K by 2 whole square. Half of that, half of pi r square. That is the area of the semicircle. From this, what do? We subtract this segment and this segment. Segments are going to be identical. It's an equilateral triangle, semicircle. So join this. Right. So from sector, subtract triangle. Triangle, luckily enough for us, is an equilateral triangle. So this area here, this is going to be, this angle in between is 60 degrees. So 1/6 of a circle, 1/6 of pi into K by 2 whole square minus √3 by 4 into K by 2 whole square is this segment. Why √3 by 4 into K by 2 whole square? Equilateral triangle of side A, area is √3 by 4 a square. So from sector, we subtract triangle, we get this. This into 2 is this plus this. From area of semicircle, if we subtract this, we'll get the remaining. After this, we need to be just careful with the math. So pi by 6 into K by 2 whole square minus √3 by 4 into K by 2 whole square. So K by 2 whole square is K square by 4. This is K square by 24 into 2 pi K square by 12. 6 into 4, 24, numerator there is a 2, minus, this will cancel, give me a 2, √3 by 8 K square. This is being subtracted from there. What is this equal to? Pi by 8 K square. Revert to, okay, pi K square by 8 minus pi K square by 12 plus √3 by 8 K square. What am I doing? From that, I am subtracting this. I have to subtract the whole thing. This becomes minus, that becomes plus. Not rocket science. And so LCM of these two is 24. 3 pi k square minus 2 pi k square, pi k square by 24 plus root 3 by 8 k square. This is the answer. Go back to the choices. Looking at pi k square by 24 plus root 3 by 8 k square. Pi k square by 24 plus 3 root 3 by 24. This is the answer, choice C. Pi k square by 24 plus root 3 by 8 k square. Semicircle minus 2 segments. Segment is sector minus triangle. We should be on top of this. We cannot say, look, I don't know the formula for area of equilateral triangle or finding area of a segment, any of that.